One of the crazy things that's going on in the AI space right now is that companies are trying to build autonomous AI agents. So this is something like it's an LLM like a ChatGPT or a Google's Gemini or Anthropic's Claude, and you can request that the agent do certain things, and it will go off and use certain kinds of tools, maybe access a database if it's within a company, access other kinds of AI, do internet searches, tons of stuff that it can do. And you're supposed to give it the goal, and it goes off and it does that thing. This can be, in principle, amazing, right? It's like having your own personal assistant. But it's not without significant risks. That's what I talk about today with my guest, Avijit Ghosh. He's an applied researcher at Hugging Face, and he wrote this really interesting piece with a number of his colleagues called, quote, "Fully autonomous AI agents should not be developed." There's a number of dangers that they articulate and that we talk about during our conversation, including the AI accessing tools it really shouldn't authorize, acting in ways that are utterly unpredictable, not knowing end users or owners of websites not knowing when an agent or a bot, as it were, is on their site as opposed to a person. There's all these kinds of dangers that pop up. And then there's a question about what are we supposed to do? How are we supposed to create these AI agents in a way that mitigates those risks and others? You know, all the kinds of risks that are already associated with AI, like privacy violations and bias and hallucination. So what do we do before we deploy that AI? And then there's a big question around once it's deployed and the agent is doing all this stuff, how do we monitor it? It's going to be acting at the speed of computer. Is that a thing? At the speed of computer? And no human can possibly track all of its actions in real time. So what does real-time monitoring look like? What does it look like to oversee that thing? And here's a question that some people are considering. It's, should we have AI monitor the AI? But of course, then there's a bunch of issues about if we can't trust AI in the first place, why would we trust another AI to do the monitoring? But there's actually some reason for thinking maybe that's plausible. And then there's this sort of broader question that we talk about, which is something like, all right, look, there's going to be this giant AI ecosystem. So there's going to be all these, potentially anyway, all these different AI agents acting to various degrees autonomously. They'll be interacting with scores of tools and websites and databases and other non-AI systems. And what would that sort of ecosystem have to look like? What would the ecosystem, what kind of guardrails would it have to manifest in order for us to think that deploying fully autonomous AI is sufficiently safe? Okay, that's what this conversation is about. It's very cutting edge. And here's a spoiler alert. We're not ready. Companies, no one is ready for autonomous AI agents. The ecosystem that we need, the kinds of capacities to develop and deploy and monitor these things safely, we're just not there yet. And that's what Avijit is going to talk about. Okay, if you are one of the many people listening to this podcast on a mobile browser, please go to Apple, Spotify, blah, 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 and go subscribe there so you automatically get new episodes. If you like this show, you might like my book, also called Ethical Machines, and or my Substack, reedblackman.substack.com. If you want to email me to complain about anything or recommend anything, you can email me at em@reedblackman.com. And finally, if you want to hear me speak at a conference that's coming up very soon, June 12th to 13th in San Francisco, I'll be speaking on June 12th. It's in San Francisco. It's the Compliance in the Age of AI conference. If you want to learn more about that conference, you can go to opalgroup.net/ethicalmachines, opalgroup.net/ethicalmachines. And I have a discount code, READ, REID, 50, READ 50 is the discount code for 50% off. I would love to see you there, and you can pepper me with very difficult questions. For now, you can listen to me pepper Avijit with, I think, relatively difficult questions about the safety of fully autonomous AI. So Avijit, all the rage, apparently, is creating AI agents. And the cool thing, allegedly, about AI agents is that it can go off and do a bunch of stuff for you. Mm-hmm. And the word that a lot of people like to use is autonomy. We've got AI that can act autonomously. And you and some colleagues recently wrote a paper that said, no, don't do that. Creating autonomous agents, AI agents, is a bad idea. So do I have that right? That's the sort of general view? And if so, why? What's so bad about it?
Yeah, so when we go ahead and say autonomy is not just this one thing, right? There are different levels of autonomy. So you could, in some ways, claim that your Tesla car is autonomous because it does have self-driving mode, but it's not fully autonomous in the sense you can still step in and take the steering wheel, right?
Yeah.
When we are moving towards this new era of autonomy with agents, we first came from the chatbot area, like we were writing questions, getting answers, and it was not really agentic in the sense it was not going out there in the world and doing things.
Yeah.
But now people are adding tools. So that's one level of autonomy in the sense, okay, now the model knows that there are tools out there that it can access and do things and scrape the internet. But that is still having some level of human control. What we are claiming in the paper is that when you completely cede control to these models, which are still not perfect, right? Like even to
Sure.
this day, models hallucinate and whatnot. We don't know what can happen. And until we do know, it's not a good idea to develop them because once it's out there in the world, it might make copies of itself and start to wreak havoc. So should we
Hmm.
really be deploying and developing and then releasing them out into the wild without any sort of safeguards? So that's the point of the paper.
Okay, so there's a couple things there. Is the idea that it's a bad idea because they're inherently unpredictable? Is it that there's a bunch of things that we've identified that would be bad, and we
Mhm.
don't know how to stop those bad things from happening? So apart from the lack of predictability, it's the bad things. But then you also said at the end, we don't really know how to create the appropriate guardrails or to monitor it. So is the thesis don't create autonomous AI, or is the thesis don't create autonomous AI until you have XYZ security or safety measures in place as well, monitoring and guardrails, stuff like that?
So that's a good question. And what I'm saying is that we don't know as a researcher community what this XYZ are. Like we can keep building different
Hmm.
guardrails, and I'm hoping we get into some of these at some point. But I, as a person, would not go out into the world and release something that can like self-replicate and go and trawl through anyone's file systems and whatnot,
Yeah.
because I don't know how do I go in and stop. So like we had in the past worms, like self-replicating copies of programs that used to take over people's computers and used to fill them with copies of itself. Currently agentic systems are going doing that in the sense they're going on the internet, the open internet, scraping and whatnot, and there are safeguards there, but I would not give a model a ton of capabilities without any way to step in and stop if something goes wrong. And therein lies my problem. And there's like examples from the past where automated systems were given some sense of autonomy, but there were still human operators who would come in and stop, for example, in war systems.
Okay, let's pause on this or focus on the self replicating bit because I've heard that sort of thing before, of course. Sounds pretty scary because what it sounds like, especially to the layperson, is a single AI will create an army of AIs. And once you're talking about an army of AIs, it already sounds pretty militaristic. It sounds scary. It sounds like it's going to take over. And so you wouldn't want that. Can you say more about the worms thing? So I take it these are non AI pieces of
Correct.
software, right? So what's the history of the worms and how do they go about self replicating? And then relatedly, if AI does the same thing, why is that so problematic? Aside from it's taking up a lot of hard drive space or something along those lines.
Yeah, I think I don't remember all of the dates off the top of my head when
Yeah,
Worm
yeah, whatever.
and Horses were a thing, but effectively, Worm is a program that can replicate itself. And if you found a way to put a worm on the internet by somebody downloading it, it would just take up people's hard drives. I think the parallel I'm trying to draw from those things. So the only way to get rid of them would be to like make sure that it does not go out. So you put it in a sandbox environment and whatnot. There are similar parallels to what people are doing right now. So Hugging Face has our own agent framework, small agents. It does have the power to access the internet, but it does not go on the open web. Like it runs programs in a sandboxed environment in EC2
Hmm.
content. So we are trying to prevent these programs from actually impacting the open internet. And like reading is fine, but not writing to it. So that's the safeguards we're
Oh,
building,
that's interesting.
right? So that it doesn't go and do stuff
Okay,
uncontrolled.
so I take it the worm thing. That's just like a kind of cyber attack, right?
Yes,
You
yes.
create some piece of software, it goes on the internet. I inadvertently click on some link or I go to some URL, and my computer downloads this piece of software. Maybe it's embedded in a piece of software that I did want to download, and I didn't know it had this sort of secret code in it. The worm goes onto my hard drive, and now it just keeps creating copies of itself. Ultimately, what? Just like gunking up the works and breaking my computer? Is that the idea?
Yeah, basically. And if you put in actual malicious code in there, then it will do actual bad things. But it is important to remember that the first worm was created by accident. And
Hmm.
it I think it was a PhD student who was trying to count the number of computers on the internet or something like that. So the student wrote divide and conquer type recursive code. It ended up becoming a file that copies itself again. So we
Insane.
talk about bad things be coming from people with bad intentions, but that's
Sure.
not always the case. Bad things can come from people
Yeah.
with good
Yeah.
intentions.
Yeah.
Um,
And so let's take, I'll use ChatGPT, I'll use Claude. Both of them now have access to the full internet, right? They can search the web, which is an amazing capacity.
mhm.
You're saying that's a bad call on their part? There's something unsafe about that, or at least the way they did it, and that there's a different way of doing it, the Hugging Face way of doing it, that makes it safer? Or is it really, as long as OpenAI and Anthropic did make it so that they could write to the internet, they could write content, then it's on the sort of safety up and up?
So there are two things here. Number one, web traffic. So you can still potentially do DDoS attacks, not just by writing, but also reading. If you just visit a website many millions of times in a few seconds, that
Mm-hmm.
server will be overwhelmed that it's a cyber attack, right? And DDoS attacks are already pretty easy to accomplish. And there are ways that Cloudflare and whatnot, these DNS servers, they try to prevent them. And there are systems in place. But that sort of attack just becomes infinitely easier with an agent because you can just write natural language to do that if that agent is able to go on the open internet. So I think these safeguards have to come from the tool itself. Whoever's making the
Mm-hmm.
web visiting tool, they have to have the safeguards. The other thing is writing. Writing is a very bad idea. Like you could just submit garbage on Google
Yeah.
Forms, just fuck up somebody's online presence and whatnot.
So they start writing a smear campaign on Reed Blackman.
Yeah, if somebody writes an agent to do that, sure, I can see that happening. That's especially worse if you don't have a kill switch or any way to step in and stop that agent. So right
Yeah.
now, if have you ever used Manus, the Chinese
No.
agent? Okay. So even Manus, when it like, okay, so you ask Manus,
What is Manus? Is Manus just like a ChatGPT or a Claude or a
no,
Gemini?
Manus is like an agentic chatbot or like
Yeah.
it's an agent developed by a Chinese company.
Okay.
So if you go to Manus AI, it looks like a chatbot interface, but when you ask it to do something, so you say that, get me the best flight prices from Boston to Kolkata or whatever,
Yeah.
it spins up its own sandbox instance of a computer, and then that computer actually like boots up and does all these things. So that computer can run code, that computer can go to the internet, blah, 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 blah. And when this task is done, after the data is written in the output, that instance of the computer is killed. So that is like a prevention mechanism because the sandbox system, it does not persist. That's, I think, a decent way of doing it. But what I'm saying is that also while the computer runs and does all of these steps, there is a pause button. So you can kill the process manually when
Mm-hmm.
as you see Manus doing these things. If somebody like hooked an LLM to a computer and gave it full access, so imagine like Anthropic's computer use without any way of stopping it, and you told the LLM to do something bad, and say you got past the LLM's filter of refusing to do that,
Sure. Sure. Yeah.
you just not have any way to stop it. So that's what I'm talking about, like full uncontrolled autonomy, wherein nobody can step in.
And is that sort of? I, I guess I'm wondering: is anyone trying to do that? Is anyone trying to make a kind of? The refrain is you can always unplug it.
Mhm.
You can always unplug it. So are people trying to make, or is there a worry that people are going to make AI agents that you just can't unplug, that you can't touch, that you build a thing, you say, I want you to carry out such and such a task, and then there's literally no way of stopping the thing?
Okay, first of all, most commercial AI apps are not running on people's local computers, right?
Mm-hmm.
They're running on distributed servers. So who will go and physically unplug? A bad
Mm-hmm.
thing happening. That's number one. Number two is if we are
Sorry, do you mean like I'm accessing ChatGPT? ChatGPT lives over there, doesn't live on my computer.
right.
And so technically, yes, someone could unplug it, but it'd literally have to be someone at OpenAI or something who gets wind of what I'm doing and then literally goes over and unplugs the thing, which probably would unplug and bring down the whole system as opposed to bringing down my interaction with it or
Yeah,
something
or
like
if they
that.
can identify where your instance is running and unplug it. But what I'm saying is that this just, I don't know if it's as well thought out as we would like it to be,
Yeah.
which
So there
where
might be some like in principle safety cord to pull, but we don't actually know where the safety cord is and who should do the pulling.
yeah, I don't know if AI models are dependable yet. Like even now, if you go to the most up-to-date model, it will
Yeah,
still do hallucinations, it will still do mistakes. Yes,
sure.
they're reducing over time, but there is no guarantee. So like my biggest worry, or our biggest worry, is that when we are not 100% sure of the accuracy and the dependability and the trust of these
Yeah.
systems, should we amplify those risks by making them agentic or working independently as sub processes?
Hmm.
So a way we like to think about in this paper is, say for example, accuracy.
Yeah.
Accuracy is a value that we care about. I want my model to do something accurately, correctly. And say it has, I don't know, 97% accuracy on a task.
Yeah.
Say I'm asking my model that here are a list of resumes, find me the most competent people. And this
Yeah.
is talking about a non-agentic chatbot, and it gives me whatever. Now say I have made it into an agentic system. I'm now saying, instead of saying these are the resumes, I'm saying go on LinkedIn, search for the best candidates looking for an accountant job in Boston, and make
Hmm.
sure that the selection that you create does not violate federal hiring laws. You have to have
Okay.
some sense of non-biased ranking of candidates, otherwise you
Yep.
violate the EOC. So the agent then thinks, oh, the user has asked me to go on LinkedIn and scrape. Fine, that is a pretty easy directive. Additionally, the user has asked me to be unbiased and not violate the EOC guidelines. So what do? Let me go online and download a tool that sort of tries to guess people's demographics. So
Mm.
your age, your gender, your ethnicity, your nationality, whatever, and make sure that the list I provide to the user is balanced. These tools of identifying people's race, gender, if they're not declared by the user, are extremely inaccurate.
Mm.
There's tons of studies. I have done the study. If you try to like just guess somebody's ethnicity based on their zip code, it
Mm.
is never very accurate. So all of these reasons, or you can never tell mixed race people from their face. So these inaccuracies from these online tools or whatever tools are provided will compound. So the final result you'll probably get is, in my projection, going to be even more inaccurate than.
Mm.
So when you chain a bunch of not fully dependable tools in an agentic fashion, the
Yeah.
final outcome you get leads to a breakdown of this one value we care about, which is accuracy.
I see. Yeah. I like that example a lot because the way that I think about the autonomy of AI agents is something like you give it the goal, but you don't specify the how it should go achieve that goal.
Correct. Yeah.
That's the beauty of it in one way, right? Because you don't have to say, first go to this website and then perform this search and then do that search and then take the results and put it like you, that would take forever, right? The whole beauty of AI in the first place is that you don't do line by line coding of directions just for even narrow AI, just regular old school predictive AI. You don't do that sort of thing. So the beauty of AI agents is you tell it the goal. I want to fly from Boston to Calcutta. You don't tell it the how. And your point is that there's so many ways of doing the how. There's so many different sort of paths the AI might take. And so many of those paths are the wrong path to take, ethically, reputationally, legally. If you don't have a way of circumscribing the set of hows, it could very well go down one of those really bad paths. So for all you know, when you say do it according to the law, so don't discriminate,
Mhm.
and it figures, oh, I know how to do that. I'll look at the pictures and look at the skin tone of the people in the pictures on their LinkedIn, and I'll make sure that the pictures, like the people that I invite, are like the pixels that represent their skin tone are of the sufficient variety. The way of going about it, but
Correct.
if you didn't specify, don't do it that way. Now you got a real problem on your hands.
Yeah, no, totally. And so in the paper, we look at, or also in the op-ed, we look at not just this one value, but other values like interoperability, sustainability, trustworthiness, a set of different values that one might care about when they're deploying a system. And we do find that based on just looking at what might happen with increased autonomy, most of these values actually break down in the face of highest level or fully autonomous. The other thing that you mentioned, which I think I would like to hone in on a little bit, is specifying the how much you specify the how actually adds to the level of agenticness. So if
Mm,
you specify what online tools it can use, that's one
yeah,
level. If
yeah,
you then re-specify whether these tools are interoperable, if you specify how many steps it can take, if you specify the in the chain of thought that is going to be generated, at what points should it try to predict the next step instead of calculating the next step. These are all
yeah,
levels of autonomy. So you can go anywhere from like a code running agent computer
right,
use, that which is like very autonomous, all the way down to literally like a set of tools. So like you mentioned, Boston to Kolkata, if it only has access to Skyscanner and including the internet and I don't know, display system, it will only do
yeah.
these two things.
So I guess the point is something like we at least have a bunch of tactics for mitigating the risk of the AI going sideways, the agentic AI going sideways.
Yeah.
And that's to get really specific, or as specific as one can without it's taking too much time, how to do it, including, I take it, limiting what it gets connected to, limiting what it allows itself, or as it were, to connect to. So you're not allowed to use this website. You're not usually use that website, or the websites of this form, or something like that. You can't use those. Or you have to use Google Flights, or you have to use.
Correct.
And then there's milestones of checking in. Check in with me every 10 steps. Check in with me every 20 steps.
Yes.
And so I guess what you're advocating for is, I have two things I want to say. One, what you're advocating for, and two, how sustainable or how scalable this model is. So what you're advocating for is really a suite of tactics for fencing in the agent so it's not that autonomous, that it's continuously looking for human approval. That's green light. Is that right?
Yes, and I think there are a bunch of other tools in the arsenal that we can use, like just general good cybersecurity practices. So one thing that, I've been asked by many people is, hey, I'm running a website. How can I tell if the person attacking me or entering data is an agent or a person? So we need to think more about attribution. So there are tools like identity binding. So like whenever an AI agent visits the internet, can you change the headers of that browsing tool so that the website intercepting that traffic knows that it is from an agent? So like that sort of verification. Also, the other thing like we just talked about are verified tools. So if the agent has a menu of tools to choose from an online marketplace, can those be certified as like clean, not having bugs and whatnot? Yeah.
We want to have like, you can use the list of approved tools, and these tools are approved because they've undergone the appropriate due diligence to make sure, for instance, they don't contain worms, to use a sort of.
Yeah. Also, like team very clearly making infrastructure around how agents communicate with each other or with other tools. So Anthropic has, I believe, Model Context Protocol, or MCP, that is pretty popular and people are adopting it. We, Hugging Faces, Small Agents actually just released MCP compatibility. So now small agents will actually be able to interface with MCP tools. So that's
MCP?
Model Context Protocol. It's a shared language between agents so that it can talk to each other. So instead of using natural language or code or whatnot, it is in a specified structure so you know what to expect in terms of code versus action that comes out of that code.
So you type in some English request, go find me a flight from Boston to Calcutta. It translates it to some sort of like computer language, agentic AI language.
Yes.
And then sends it to the googleflights.com AI agent who reads it in that language and then does the thing. And I take it, number one, that's more efficient for some reason. And number two, it makes attribution easy because we know the request is coming from an agent. Is that the idea?
Yes, I think theoretically, yes. I don't know if a Google Flights tool or agent exists.
Sure,
but
as an example.
did exist and was using MCP. Yes, that is how it would work.
I see. Okay.
There is no like hard standardization yet because it's so new. It's still the Wild West. But yes, people are starting to coalesce around this shared language.
Okay, so this all sounds reasonable. I take it that the idea is supposed to be ultimately autonomy is a volume switch. You can turn the volume up, you can turn the volume down.
Right.
You're going to turn the volume up. Maybe you start the volume low, but you're going to turn the volume up. Number one, if the stakes are super low, right? If the stake, then you can give it more freedom.
Yes.
But also the volume can be turned up as it probably crosses certain thresholds of reliability. Okay, I've told it to do this task 1,000 times or whatever. And we have such and such guardrails in place. And every time it's done it, all right, I'm going to let it do, instead of the 20 steps that it was doing, I'll now let it do 40 steps and see how it does there, because it's quote unquote earned the trust or something along those lines. I guess my question is, how far could it go? And relatedly, there's a lot of weight on the human to ultimately say, yeah, this is cool, this works, I'm okay with this. But this is getting paired with the increasing complexity of what the person has to oversee. So you have an agent, you have an AI agent. It can be connected to, number one, the internet. Obviously, there's lots of stuff, and there's a tremendous amount of data there. And it can pull from all sorts of places, some places that might not be properly verified. If you're looking for political news, it might pull from a Breitbart or a Fox News. It might pull from an MSNBC. So there's like bias issues about where it's pulling from. And then there's the stuff that you specified about, like, it goes and looks in a way that turns out to be biased or discriminatory in some fashion. But okay, anyway, so it's got access to the internet. And then it has a bunch of access to other AI models, right? So other generative AI models, other LLMs, perhaps accesses a model that's really good at audio generation and a different model that's really good at video generation and a different model that's good at whatever. Then it can also have access to narrow AI models, right? So it just needs to, it takes that, takes all the, you tell it to go run the resumes and it takes the resumes. So it's also connected to a database. So you connect to a bunch of databases connected to the database of resumes. It takes all those resumes, it feeds them through the narrow AI that gives them a risk scoring, and then it reports to you on which of the most likely candidates, blah, blah, blah. I'm just trying to draw out a picture that the AI agent is increasingly interacting with this giant ecosystem of
Hmm.
other technologies, be they other kinds of, be they other agents, be they other generative AI models, be they narrow AI models, be they databases, internet, whatever. And then I guess I'm wondering, is it feasible for a human to get their head around all that complexity to say, yeah, cool, keep going, green light? Or is it too much data for a human to be there to give it the green light in a way that actually reflects an understanding of all that complexity? Because it seems, on the face of it anyway, like that's impossible.
I think you basically have outlined the scenario that I'm afraid of. For high stakes situations like warfare, I
Yeah.
would not deploy an agent that is so autonomous that you cannot like trace the steps in between. And this has happened, like we have been here before. So in the 80s, this happened on both sides during the Cold War. I think in 1980 there was a Soviet missile attack scare, and instead of like automatically sending missiles back to Russia, people investigated a little and found out that that one of the machines had a problem and the readings were wrong, but because there were fail-safe mechanisms, they were
Mm.
able to track that it was an error. Similarly, again in 83, the opposite thing happened. Russia detected like three missiles or four missiles coming from the US, and the human operator was instructed to like fire back. But
Yeah.
then he thought, why would the US only send four? Wouldn't they send like thousands? So
Mm.
they again found that it was a machine error and a
Yeah.
human at the end of the day prevented it.
Yeah.
So I guess what I'm trying to say is that if you're doing something low stakes where you
Yeah.
don't need to be involved in the small things, even if that goes wrong, like I don't know, say Amazon Alexa Plus is coming out very soon and it's an agentic system. You can
Mm.
actually tell Alexa Plus to go online and find me somebody to repair my light bulb. Like it's
Mm.
in their product ad. Given that you have secured the ecosystem of the different tools that Alexa will access to get there, and I think Amazon already does this. So Amazon already sells a marketplace of Alexa extensions.
Mm.
I'm assuming that if Alexa only can go through these verified extensions, which have already been tested for worms and whatnot, it is low stakes enough that you don't expect something horrible to happen. You've just asked it to go on Fiverr and then
Yeah.
it looks for people or whatever.
Yeah. Yeah.
Yes, the errors can still happen, but those errors are low stakes enough that I would trust it. So it's
Yeah.
very case by case basis.
I don't know if this is devil's advocate. Let me just try out a thought. Part of the problem that you've highlighted is that you can't predict how the thing's going to act.
Right.
And so you think something is low stakes, but then it does something weird in pursuit of those low stakes, which turns out to be a high risk or high impact, really bad thing. So I guess I'm wondering, given the unpredictability of agents, unless the right kinds of guardrails have been put in place, and maybe even if then, I don't know, can you actually know what the low stakes cases are when you have lots of steps, right? Because what looks to be low stakes, go find me the cheapest person, um, I don't know. There's probably some stupid causal path that might result in some people being seriously harmed, even though you wanted to do some minor thing. And why did it do that stupid thing? Because it's an AI and it does bizarre things sometimes.
Yeah, I don't know. I feel like there has to be a balance between automation and autonomy. These are not the same thing, to be fair. Automation is not something we can prevent. It will happen over time. Things have
Mm-hmm.
become more and more automated. Like we used to have jobs for people opening doors and now they're automated,
Mm-hmm.
which is not the same thing as agency or autonomy. So you could still have these very
Yeah.
fantastic automated systems doing these things, but as long as you keep some sense of agency there, that is helpful. So, like for example, when you call an Uber and you get into the Uber, up until that point, if Uber did not provide me a way to report to somebody or call 911 or whatever,
Yeah.
if I just got into a stranger's car and did not have those tools, I would not have agency. But having those help me tools gives a sense of agency to me,
Mm-hmm.
to the human, and therefore I've not ceded all control to this ecosystem. Think if you think about that task of getting from point A to B with the tool Uber,
Yeah.
as like an agentic task. I'm just like making a very rough assumption.
Yeah, sure.
And through any part of this process, other than starting the task itself, which yes, you called the Uber, during the happening of the task, if you did not have any agency, that would be a much scarier thing. But
Hmm.
because
Hmm.
people have agency, they have tools at their disposal. They can, I think, trigger audio recording in some countries throughout the
Yeah.
entire drive and whatnot. You have some recourse. So I think we're not saying in the paper don't build automated systems. You should, because it does make people's lives easier,
Yeah.
but make sure to have these hooks of accountability throughout the process, because if you give overall agency, that's bad.
Yeah. Okay. Let me take a slightly different tack now. I feel like we've been talking a lot about preventative measures.
Right.
So before the AI is deployed, before the agent is deployed, before it's doing its thing, make sure you limit its access to various tools, make sure those tools are vetted in the right kind of way, maybe specify certain ways that it can't go about doing a task, so on and so forth. Then the thing goes off and it does the things. I'm wondering about at least two kinds of things. One, I'm wondering about what does real time monitoring look like, especially if you've got multiple agents talking with other multiple agents, like your agents talking to all their agents, and there's kind of a conversation of agents in, as you said, a kind of a foreign language. It's hard to, I'm not sure what real time monitoring looks like, number one. And it doesn't look like it's the kind of thing that can be done by a human since it's going to get done so quickly. And then relatedly, what do intervention methods look like? So once whatever the monitoring looks like, once it starts flashing red, if it's an insanely complex system and your automated monitoring system starts blinking red and it calls the human and the human says, okay, what am I looking at? And then it's just this complete mess of a tremendous amount of data. The human is not going to know how to intervene, even though they know that something has gone sideways. So can we talk a little bit about that? Not the proactive stuff before the agent is deployed, but while it's in action, what does monitoring look like and what does intervention look like?
We don't even have live monitoring for baseline AI models to begin with. I don't like
Hmm. We
say
have things
chat.
like monitoring for model drift or data drift, stuff like that.
Yes, and I wrote a paper on data drift actually, or yeah, concept drift when
Yeah.
you're measuring fairness. But it's not, what I'm saying is that it's not implemented by systems. Yes, there are like tools like Fiddler, they do this
Yep.
bit
Yep. Yep. Sure.
monitoring. But I would say yes, we if you can have like monitoring, great. If you can have tool level monitoring, also great. But more importantly, I think we are not doing enough as an AI community in
Mm.
disclosure even. So, for example, in the cybersecurity world, you have the 30-year history of vulnerability disclosure or the CVD ecosystem that's maintained by MITRE. We don't have anything like that in AI. So all of these harms that you read about, did something like that,
Yeah.
Claude did something like that, these are all happening because people are either going on social media and getting a viral tweet, or they're going, I don't know, or the media is proactively looking for this, or somebody's viral tweet got posted to the media, or somebody filed a lawsuit against some
Uh
company.
huh.
We don't have a centralized repository of harms for people to monitor. The other thing to keep in mind is that
Mm.
these sort of errors are transferable across systems. I don't know, if you find a way to jailbreak ChatGPT, it is more likely than not that it would also work on Claude, it would also work on Llama and whatnot.
Oh, interesting.
But because companies are not talking to each other in terms of the kind of reports they're finding, we
Mm.
are all in the dark. This does not happen in traditional software. Like when a
Mm.
bug like the heartbleed bug happens, it goes into a centralized repository, including how they were found and what the solutions are. So
Yeah.
we need that, first of all, even more than complex monitoring.
Interesting. So I take it your response to me is something like, "Yeah, Reed, that'd be great, but we don't have we don't have the capacities to at the moment anyway. We don't have the capacities to monitor agents in real time, and thus relatedly, we don't have the intervention methodologies other than to see that there's a fire and then hope that someone has specified where the safety cord is and we
Yeah.
know how to pull it."
Yeah, and the other thing I think like interpretability research is important even now. Like people do
Hmm.
work still on mechanistic interpretability. So the chain of thought stuff branched off in different directions, including agents. But one sort of goal of that line of research was to see how an AI model's answer came to be. What were the steps it took to get
Yeah.
there?
Sure.
What I'm trying to, I guess, say is that it is a good thing that in UXs like Manus, or even, I don't know, I think Grok does agents as well these days.
Hmm.
When you give it a task, it actually talks about all of the steps it's taking in between.
Hmm.
So yes, you will have a deluge of information if something goes wrong in the end, but at least you can trace them back. I think we need to do that task with more care, more better UX design, so that if something
Mm,
goes wrong in a tool, you can know where to look at.
yeah. I compare it to fraud detection. So when an AI, not a generative AI, not an agent, just a regular, is looking through a bananas amount of financial transactions, and then it flags something as potentially fraudulent, and then it goes to a person, a fraud agent, to say, "Hey, take a look at this."
Right.
If it gives it, if it gives the person all the reasons, as quote unquote reasons why it flagged it, the human's going to be like, "This is a 150-page document written in code. I don't have a damn clue what this says. It's useless to me. I don't know why it flagged it. I don't know what to do now." If it gives too little of an explanation, it's the person is again going to be like, and so figuring out, okay, how do we, when a financial transaction is flagged for being potentially fraudulent, how do we communicate to the fraud agent, the person,
Hmm.
the information they need to know so they can do their job?
Yeah,
And I
and
take it we've done that kind of thing for fraud detection, but we haven't done that kind of thing for the operations of AI agents.
there is a task or benchmark called needle in the haystack test where people
Mm,
do look at that. So if you have a deluge of like 150-page report and
yeah,
something somewhere is the needle that you're asking the model to find, how well it does. So companies and developers are working on it. It's again, like I said, if we're going into this agentic world where we will have this deluge of information for even normal tasks, before we perfect models being able to find that needle in the haystack without hallucinating, should we go
yeah,
and deploy them in those large scale systems? So that's what I'm
yeah.
saying. I think we are, this agentic hype is putting the cart before the horse. Like first we need to perfect single systems, then we go into these type of agents. So I would
When you
say
say,
what the world is ready for right now is one single model having access to a set of verified tools that we can do.
yeah,
But having agents talk to each other, go crawl the internet, even write data, those we're not ready for. That's like a level of
mm,
autonomy we don't have the human capacity to monitor.
yeah. I guess the idea is if it's just a single model that has access to the pre-approved, authorized set of tools, that's sufficiently fenced in such that it's not going to do anything bananas because you have a human at the end of it.
Right.
Kid, one kind of thought that's been kicking around it's in the ether is that the systems are so complex, et cetera, et cetera, et cetera, that we can no longer rely on having a human in the loop. So there's ethical reasons for having a human in the loop, like, oh, we got to keep the humanity in AI, blah 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 blah. I don't think that's particularly persuasive. Put it to the side. I think human in the loop as a sort of ethical risk mitigation strategy is reasonable, right? We need a human in there because we need a person's eyes to who can understand greater context, blah blah blah. Okay, so see it as a strategy. But if it's just a strategy, you might think that there's some other kind of strategy that would do just as well, if not better. And so some people have floated the idea of not having a human in the loop, but having another AI in the loop. So you have an AI doing that kind of real time monitoring, checking the results and asking for the reasoning. It's all, of course, that's all happening behind the scenes in real time, but the AI in the loop to check for whatever it is, fairness, concept drift, everything from technical, data scientific, the ways of things can go wrong to ethical, reputational, legal ways of things going sideways. So, what do you make of that?
Do I really trust a model that is not deterministic in nature
Mm-hmm.
to be able to be the check and balance for something else that is also not deterministic in nature? I don't. There's still, okay, there are problems that AI models are very good at solving very quickly, like grammar checks and whatnot. But
Mm-hmm.
there are still very easy problems that models struggle with. Like last year, the whole rage was strawberry, counting number of R's.
Yeah, yeah, yeah.
So easy
So
for humans.
dumb.
So what I'm saying is that in your hypothetical scenario, if I had another model to see if the model is correct, both would fail because they're not there yet. So maybe the answer here is to have to first validate the discriminator model itself to see if it does sufficiently well, like 99 whatever percent accuracy on
Yeah,
this thing that you're using it for checks and balances, and then move it. And people do that. Like we have written old school mail spam classifiers. They're
yeah,
not even AI, but they work well enough that Gmail uses them. So
yeah,
we actually don't get a huge majority of the spam that is sent to us. But unless those are reliable for that purpose, I don't know if we should be chasing them as discriminators. That's my other problem with general purpose models as or frontier models as the be all and end all.
mm,
Two things. First of all, do we even know what AGI is or looks like when we are
sure.
chasing and putting all of these resources into this general model that will solve everything? Number two
Yeah,
is it takes away from the human and other research that we could do in solving real problems. So if I build an AI to help people with speech disabilities, that process looks very different from building a general purpose chatbot or building an agent.
Sure.
So like purpose built AI, I think is much more useful than having this ultra powerful model check for any mistake in the line of agents.
This was back, I had a conversation with Peter Lee at Microsoft. He's the, I don't know what he's doing now, actually. This was a couple years ago, but he was at least the head of AI research for healthcare and life sciences. And there were two kinds of things that he said back then, and I don't know what the research shows since then, so I'm asking you. One is that, no, whenever he was talking about healthcare in particular, and especially differential diagnoses in healthcare, so trying to diagnose patients. And he said something like, we tried medical specific or diagnostic specific large language models. Maybe there were small language models at that point versus general purpose. And ChatGPT 4.0 at the time outperformed the medical specific one. So I guess one question is, while it might sound like the built for purpose AI is going to be more accurate, it's certainly possible that the general purpose one is more accurate. And according to Peter Lee, at the time anyway, it was more accurate. So one question is around that. I'll stop there. And
Yeah, no, definitely do your evaluations on whatever task you're doing. But I think also we need to get out of this paradigm of general purpose versus special purpose LLMs, because that is still one particular type of AI model. So
mm,
protein folding models, for example, very
yeah,
useful in biology. They are not
mm,
LLMs, but they
yep,
are AI.
yep, yep,
And we don't talk enough about them because the market has been captured by LLM models and people
yep,
who profit from selling these products. So I would say like purpose build a system that does the best output for the
yep,
task you're trying to do. And if the task is protein folding, I would probably not train an LLM to do that. I would use models that do work.
yeah, that makes sense. One more thing that Peter said back in the day was he gave examples of, I'm going to talk about LLMs because that's what he was talking about. LLM number 2 correcting the mistakes of LLM number 1. It goes back to the AI in the loop thing. So even though you might ask an LLM a question to solve a problem, it'll say, here's the answer, here's the reason behind it. And you say, are you sure? It says, yeah, I'm totally positive about this. But then you ask a different instance of the same model or a different model altogether and say, hey, can you take a look at the answer that it gave me and critique it and make sure it's right? And it'll find mistakes that first model missed. And then relatedly, one of the things that's been going on is like these things engage now in a kind of self-reflection, metaphorically speaking, right? That internally behind this, you give it a prompt, you ask it a question, it does some calculations or it does some predicting of words or tokens, whatever,
The
and
thing,
then it comes up with a thing, and then it critiques itself, and then whatever the result of the critique is, that's your output. So does that stand as, I don't know, decent empirical evidence that having AIs correct themselves, correct other AIs is a plausible path forward?
yeah, okay, so inference time compute actually has shown to help with task performance. And I'm not denying that, like just to be
Right.
very
So the longer it quote unquote thinks about it, the longer it processes the data
yes,
does.
it
Yeah.
is, it does better. But at the same time, there are still black holes or blind spots in models because based on how they're trained. So a new thing that I just saw on X recently is if you give all of these models a picture of a chessboard and
Yeah.
saying, give me the solution to mate in one, even
Yeah.
though mate in one solution does not exist, because
Yeah.
these models are trained to think and think until it does find a solution. Because of how these models are trained, they are led to believe that a solution does exist and it just needs to think harder and harder. So it just
Uh-huh.
will fully make up like a fake board, or it will give a
Yeah. Yeah.
solution that's completely wrong and whatnot, or like
Yeah.
moves that are not legal. So
Yeah.
they are getting better, but again, there are blind spots. And can,
Sure.
like I keep coming back to my original question, can we afford to deploy a seemingly pretty good system in a high stakes
Yeah.
scenario without any control when these blind spots continue to come out with every new model?
Yeah. One more question. Maybe this is my last one.
Mm.
You said that where we are is we're at a place where we can take single models or single agents and have them do the thing, connect them to the thing that you want to connect them to, et cetera, et cetera, et cetera. But we're not ready for, I'm not, you didn't say this, but I'll put it this way. You tell me if I'm mischaracterizing your view. We're not ready for agentic AI, where there's lots of agents doing lots of things and talking to each other, whether it's internally or your internal set of agents talking to an external set of agents. Is there, or what is the milestone that would need to be met? You say, okay, yeah, we're ready for phase 2. We're ready for
Great.
doing more than just. the single agent with the pre-approved access to stuff.
Yeah, so I think you bring a very good point that I've been dying to talk about, which is agent infrastructure. So there
Mm,
is this really cool paper by Alan Chan and a bunch of other authors on agent infrastructure, and we need several things before we can live in that world. I talked about attribution a little bit, identity binding, certification of tools, also having agent IDs. So
mm,
even if one single model, say there are two people using ChatGPT and both of their ChatGPT agents go online, you need to have separate IDs to see which task came from which user. That also not just attribution, but helps with liability. But more
yeah.
importantly, I don't think the internet is ready for a swarm of
Mm,
agents to troll around. For example, or most directly, the current internet that we use are made for humans with
yep.
mouse and keyboard and visuals. Agents don't need all of that. Yes,
Right.
currently they can move around the screen and try to take screenshots and see where
Sure.
things
Sure.
clicked. But I can think of an agent forward internet being more text heavy, behind the scenes, having
Yeah.
maybe things like MCP to make interoperation possible. And I
Yeah.
would also think that these companies that are hosting websites would additionally require ISPs to separate agent traffic from human traffic, so that
Yeah.
if they know a request is coming for an agent, they can redirect them to this like Web 2.0
Totally. Yep. Yep.
versus, yeah. So we are not there yet. That infrastructure is still being built. We also
Yeah.
don't have reporting mechanisms, which don't even have it for AI. I'm working on it with a bunch of authors. We had a paper out. It should come out, hopefully, it will come out in ICML soon, on coordinated flaw disclosure of models. And we need to be at a place where these sort of flaws are sufficiently attributable enough to either the tool or the model causing that activation of the error to
Yeah.
be then able to also centrally report these harms. We're not there yet.
Yeah.
We need to build a reporting mechanism that is interoperable and being used by and looked at by everyone.
So two things. I agree with you on the internet front. I actually wrote a Substack piece, I don't know, a few months back about there's going to be agents doing all these things for you. It's going to be all behind the scenes. A lot of customer facing websites are going to experience massively decreased traffic or loss of ad revenue because because the agent's going to talk to their agent. And so you're not going to need the kind of the UX that you need for lots of, because you're not going to need the kind of UX you need for people because agents don't need that kind of UX. They need a different kind of UX.
Hmm.
I don't know if you call it a UX. Anyway, I agree with you on the internet front. In order secondly, let me try to summarize everything you just said and tell me if the summary is a bad one. I
Hmm.
think that what you're saying is the next milestone that
Hmm.
we'd have to reach in order to safely deploy multi-agentic systems is auditability. We have no ability at the moment to really audit the trail of all the things, all the actions, all the decisions, all the transactions that all those agents would be doing. And
Right.
since there's no method to audit all of it, we can't possibly do it safely. Is that a fair summary?
I think that's largely correct. Yes, you might still be able to go the evaluation route and test, like you mentioned earlier, that you make an agent do a task 1,000 times and see how many times it fails or passes, and then just
Yeah,
leave
yeah,
it out
yeah,
into the world. But I feel like that's not safety by design. So for safety by design,
mm.
we need to build infrastructure around these systems itself so that we know if something goes wrong, where to look instead of getting lost in the open quagmire of the internet, especially an internet that is not designed for this type of use.
That's really interesting. So there's all these times when we think about what constitutes the safe deployment of an AI in a given context. And we have to think really carefully about the given context and what the deployment is and the stakes and blah, blah, blah. And then you want to think about on for that particular use in that particular context, what constitutes, what's the threshold for safe enough to deploy?
Hmm.
And then you figure out what your sort of, what that threshold ought to be and how you can get to that threshold. And maybe it has to pass X amount of tests and 1,000 trials and whatever it is. But that's so piecemeal. That's A, that's really difficult. And B, that method doesn't scale very well, right?
Correct.
Because it requires so much. And so if you want 1,000 deployments across 1,000 contexts, oh my God, forget it. That's going to require an insane amount of
Right.
person power to accomplish that. And I take it that your point is you could, in principle, you can do it. It'll work one off here and there, but it doesn't scale. And the only way you're going to scale thousands of deployments across thousands of content, more tens of thousands of
Mhm.
deployments across tens of thousands of contexts, is if you have the kind of auditable infrastructure that you were talking about.
Right. Yes. 100%. You hit the nail on the head.
So you published this paper, autonomous agents shouldn't be developed. And I know that there's been lots of conversation, lots of talk about the paper. I'm wondering if anything, has any of the pushback or any of the feedback changed your view at all about whether this should be developed? It seems like you're still pretty much on board with that in light of our discussion, but has anything shifted your perspective?
Yeah, so I think when we wrote it, and it still stands true that right now we don't have the infrastructure to make sure that something won't go wrong if we develop it because we don't have the guardrails yet. But now I think my thought has slightly evolved to this statement, which is fully autonomous agents should not be deployed
Mhm.
without all of this infrastructure and these guardrails that we just like we talked about throughout our conversation. Because I think there is value in autonomizing things for different needs. Like some people might require agents for accessibility and whatnot. So I
Mm.
want people to do research into more autonomy and more automation and more agency, but do it after this sort of safety first principle, build infrastructure first, and then go from there.
That's great. This has been really fascinating, Avijit. Thanks for coming on, and I'm looking forward to you coming back on to tell me about all the new developments in the creation of that infrastructure.
Thank you for having me. And yes, we are working on it every day. So I'll hopefully have good news soon.
I can't wait. Thanks so much, everyone, for listening. And now let me thank the people who have made this podcast possible. So, first of all, we have Delano Alexander. He's been with me since day one. He showed me even how to start recording a podcast in the first place. He does editing stuff. He's been fantastic, and he does really everything I ask him to and more. I've never met anyone else who just says so much. Yeah, I don't know how to do that, but I'll figure it out. What more could you ask for in a producer? Next up, Jennifer Strong, my podcast guru. I don't know what else to call her. She just has advised me on how to design the podcast, how to grow it, and she's responsible for, if you like, this kind of season 2 relaunch and everything around it. So thank you to you, Jennifer. Next up, Meg Marco, responsible for all the excellent artwork. Before I did the artwork, I didn't really know what I was doing. We put it together. It worked well enough, but I think Meg really did a phenomenal job bringing everything together. Garrett Lang, sound engineer that I frankly don't deserve. He's just too good for this podcast. Don't tell him I said that, though. Next up, Benjamin Koltgen. He is a professor of philosophy who has helped me source guests, identify who's interesting, who has things to say, etc., etc. So without him, I wouldn't have anyone to talk to. And then finally, Ashley Wasylenko, who helps with all manner of administrative things, making sure that the podcast guests find their way to the podcast, can schedule the recording, get their bios and headshots, and really just keeping the show on the rails and me organized. Thanks to all of you. Really appreciate all your hard work.